All right, an observational study can never establish cause and effect. You give vaccinations to a few people, they seem to be not getting the sickness, and therefore, I think the vaccination is working. Vaccination is the cause, the reason that they are not getting sick, but you can't really do that unless you have a formal experiment. In that case, at least a single, um, at least a single blind is required, probably double blind is required. And just for your information, during 2020, when the COVID-19 vaccines were developed, every company had to do a double blind test, okay? Because I mean, that's the level of integrity that is required to develop something as important as a new vaccine for a new found coronavirus. All right. So, all right, let's go ahead and fill in some blanks here. An observational study can establish, association, correlation. A correlation is just the fact that two factors are related to each other. Okay, so an observational study can establish that, hey, this and this are related to each other, or as one increases, so does the other. So this is like a relation or a pattern. One's height and weight, okay, so it tends, this is just a tendency that the taller the person is, typically the more weight that person has than somebody who is shorter, okay, not always. Weight of a car is related to the fuel efficiency. So the heavier the car is, typically the less fuel efficient the car is. Okay? So those are association. Those are statements of correlation or association. But those do not establish cause and effect. Again, this is one of the most important things that you should take away from this course. So I want to highlight this and I want to emphasize this. Maybe you should just memorize and just keep saying this sentence. An observation or the association does not prove causation, or correlation does not prove causation. Okay, all right. So, and this is one of the fallacies in section 1.1. If you want to go and look at section 1.1. All right, let me give you some examples, and I want you to pay close attention to all of these associations, right, which do not prove causation. All right, so let me go ahead and do this. These are classic examples. I think you should all be familiar with all of these statements. All right, the first statement says children with older moms do better in school. So people, sociologists, basically, sometimes educators maybe, they have discovered, and they have discovered this many times, the children whose mothers are older tend to do better in school. Their academic performance is better, their GPA is better. They seem to get better grades in school if the children have older moms. Okay, so that is a clear correlation. We call them positive correlation, because the older the moms, the age of the mother, and the GPA of the students, or academic performance of students, they have positive correlation. Why is it? So let me go ahead and write this down. There is a clear association between the academic performance of the child and mother's age. How would you explain that? I think I should maybe use a little smaller font because I have a lot to write here. Okay, how would you explain that? Okay, you could try to establish cause and effect. So maybe the mother's age is making the kids smarter. You think that's true? You know, as the mom gets older, the kids just get smarter and smarter. That's probably not the reason for the academic performance of the kids, right? You could also theoretically reverse that and say, maybe as the kids do better, the moms get older, right? So the better academic performance of the kid makes the mother age quicker. Oh, that's ridiculous, right? So just think of some possible explanations of this. Maybe I will write down this. Okay. But older moms do not cause kids to be smart, nor do smart kids make moms older, obviously, right? Okay, so there's a thing called a common underlying cause. And this is almost, well, I wouldn't say almost always, but more often than not, you can find a common underlying cause that's making these moms and older moms and the kids do better in school. So what would be an explanation from the sociological standpoint? Can you think of what this is? What is the underlying cause which tends to make the moms older and tends to make the kids smarter? The answer is, and I think you can understand this very easily, right? It is the moms, lowercase, the mom's educational level. All right, so think about this. The more educated the mom is, that mother tends to be older. Okay, because if that mother goes to graduate school, maybe that mother may have delayed getting pregnant and having children. Okay, so when the mother is more educated, they tend to be older moms, and because they are more educated, they emphasize education in school, especially for their children, and that kind of encouragement at home would allow the student to do better in school. So the common underlying cause in this situation was discovered to be the mother's educational level. So it is not that the older mothers will make the kids smarter, but the fact that the education, the level of the mother is causing both the mother to be older and the kids to do better in school. Right, so that is the sort of the accepted reasoning for this. So try to find, in each of these cases, try to find if there is any kind of common underlying cause. Sometimes, okay, sometimes the one is causing the other. Okay, when you see an association or correlation, but many times there is no direct direct cause and effect relation. Many times there's a common underlying cause. All right, so here's another one. This is from a recent events, April of 2020. People are driving faster in April 2020, and they were reporting very few accidents. All right, so there was a relation. Okay, the faster the people drive, the fewer the accidents. Now that doesn't sound right, right? Because if people are driving faster, you would expect more accidents. But this was happening in April 2020. And of course, if you lived in April 2020 anywhere in the world, you probably can figure out what was happening, right? Higher speeds did not cause fewer accidents. It is a mistake, a gross mistake, to say that, look, people driving faster and fewer accidents were reported, and therefore I should drive faster to avoid having accidents. Maybe if I go fast enough, I can avoid all the accidents. No, that would be ridiculous. The other way is even more ridiculous, right? Fewer accidents cause people to drive faster. No, 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 no. Though there's no cause and effect in this association that is clearly observed. Okay, so that's why an association or correlation does not prove any kind of cause and causal relations. Okay, so association does not imply causation. Make sure you understand that. All right, so higher speeds did not cause fewer accidents, nor did fewer accidents cause people to drive faster. Okay, again, there was a common underlying cause, right? What was the common underlying cause that resulted in both of these differences, or both of these trends or change? The common underlying cause was the pandemic. Okay, most people stayed home. Very little traffic was on the road. And this is the key, right? Because there were very few cars on the road, people were driving faster because they didn't have to wait and slow down. You know, when you don't have too many other cars around, people tend to drive faster. And because there was very little traffic, the number of accidents became fewer, all right? So it wasn't that the faster speeds caused fewer accidents or vice versa. The common underlying cause was the the volume of the traffic, because very few cars were on the road. That caused people to drive faster, and that caused fewer accidents, right? So again, try to look for a common underlying cause when you see an association or a tendency, pattern, or correlation. I have been using the word correlation. Maybe I should define this more clearly. Correlation is when correlation occurs when two factors increase or decrease together, or as one increases, the other one decreases, right? So that is what we mean by a correlation. Positive correlation is when X and Y tend to increase with each other or decrease with each other. A negative correlation is as X increases, the Y decreases, and vice versa. Okay, the sale of a new toaster increased when more and more people attended classical music concerts. I said concert here, and that's true too. But in this particular situation, people were going to classical concerts, and the number of people who attended classical music concerts increased. And at the same time, they saw a boost in new toaster sales. How would you explain that? Okay, toasters did not cause people to attend concerts. Is that believable? Yeah, I mean, it's ridiculous to say, you know what, when people buy toasters, that somehow make them want to go to classical music concerts. No, that's not the cause, right? Nor did concert attendance cause higher toaster sales. Okay, that's obvious, right? I mean, just because people start to go to classical music concerts, it's not like, oh, you know what? We love these classical music concerts. Let's go buy toasters. So what was happening? Okay, again, common underlying cause. Think about this. What could be a common underlying cause? This is very general. In fact, it's so general that you may not even think about it. Okay, so here's the answer. When the economy is good, everything sells. Okay, people buy more things, including toasters. Okay, and when the economy is good, people have more money and they have more time, and they tend to go to things like concerts. So when the economy is good, people buy more things, including toasters, and do more things, including going to concerts. Okay, so that's it. That was the only explanation. When people have more money, they end up buying more things. And by the way, at the same time, not only did the toaster sales go up, the sales of almost every good increased. The sales of cars went up, and sales of everything went up. And then people were doing more things. And so concert attendance was increasing, the travel was on the rise, and everything else. Okay, but again, see, if you make a statement like this, the sales of a new toaster increased as more people attended concerts. This kind of headline would almost imply cause and effect, right? Without saying explicitly one is the cause of the other. So you have to be careful. You have to make sure that you do not read something into headlines when there is no reason to. Okay, the next one, students who study classical music get better grades. This is a very common statement, you know, and in fact, many piano teachers and violin teachers will tell you this. Oh yeah, you should teach your kids classical music because those students do well. And that's true. There's clear, and this is undoubtedly, there is a clear association between studying music and getting good grades in school. All right, so the association is undoubted. It's beyond the doubt. The association is clearly shown repeatedly. Okay, but it may not be. See, we cannot conclude classical music is the cause for the academic performance. So, but the classical music may not be causing better grades. They may be. I am not saying they are not. I mean, the classical music may be the cause for better grades, but it is not conclusive. Why not? Oh, by the way, the other way is as ridiculous as it may sound. Of course, it's not possible, right? Nor do better grades drive kids to study classical music. It's not like, I'm getting such good grades and now I want to study classical music. That's not the way it is happening. But there is an underlying cause, common underlying cause. Guess what that is? You can probably figure this one out. Why do students who study classical music tend to do better in school? Think about this. Okay, so here is the answer that most experts agree on. Now, some experts still agree that training classical music, studying classical music will develop the part of brain that would help you do better in school. And it may well be true. Okay, I am not denying that. But just the fact that you see the correlation or the association does not imply causation. That is the important part. Okay, now, many people accept this other explanation of the common underlying cause, that those who study classical music tend to come from wealthier, education-oriented families, more involved in the kids' education. All right, so that is probably the cause, so if you grow up in the education-oriented family, or perhaps wealthier family, not necessarily the money, but if you grow up in a I wouldn't say well-educated either, but in a family that emphasizes education, the parents may encourage the kids to take classical music lessons. After all, lessons cost money. And because of their involvement in the kids' education, the students do better in school. All right, people who are optimistic make more money. So you should look this up. There is a professor of psychology at Yale University. She's the most popular professor at Yale University, and she teaches classes like economics and happiness. She's called Dr. Happiness or Professor Happiness. And for years, she has been studying and written books about money and happiness. Okay, does money make people happy? And the answer is yes, sometimes to a certain level, but not always. But there is a correlation between being optimistic and having a lot of money. So how would you explain that? You should be optimistic so that you can be wealthy, or does that wealth cause you to be optimistic? Certainly, that could be a possibility, right? So optimism may not be the cause. It may be, okay, but it may not be the cause of the people's wealth. Nor is more money necessarily the cause of for the optimism. Or it may be. Okay, after all, it may be easier to be optimistic when you have a lot of money, right? So that could be a possibility. And it's possible that when kids grow up being optimistic, they may try new things and they may become more successful and they may be wealthier. But clearly, there is a tendency or the correlation or association between optimism and having more money. Okay, but that association by and of itself does not establish or imply causation one way or the other. So optimism may not be the cause of their wealth, and neither is nor is the more money necessarily be the cause for their optimism, though it may be. Okay, so think of a common underlying condition or common underlying cause. What's making some people being optimistic and also at the same time making them more richer or wealthier? Okay, can you think of a common underlying cause? Yeah, in this case, one accepted theory is that those from a more secure background tend to get better jobs. Okay, so in other words, people with a more secure family or a background tend to get more high-paying jobs and not worry too much about the future. Okay, after all, if you grew up in a family that have have a, let's say, a lot of cars and have a big family, big house, and you are not insecure in terms of food and shelter and clothing and so on, the chances are you probably will get better jobs because you can afford to go to good schools and have a nice good degree. It makes you optimistic too, because you've never had to go through difficulties such as being hungry or experience homelessness and so on. So it may be just that the secure background that's causing people to be optimistic, and that would help them secure better jobs. All right, so that is a more of a understood common underlying cause. All right, the last example here. All right, I am trying to bring this point over and over again. What is the point I'm trying to bring up? Okay, let me write this in another, maybe more concise way. This is something that's quoted over and over. Okay, and in fact, if you enter exactly what I'm stating here on a Google search or something, you will probably see hundreds of sites explaining this phenomenon. Correlation does not imply causation. See how it sounds cool, right? Because the word correlation and the word causation both starts with C. A correlation does not imply causation. In other words, an observational study by itself can never establish cause and effect. All right, the last example. Across Europe, this was a this was borrowed from the beginning chapter of that Data Detective, the book called The Data Detective, which I referred to earlier. And so what does it say? Across all Europe, there's a strong positive correlation between the number of storks, birds, and number of babies. So that proves that the storks bring babies. Done, right? You have a statistical proof of that statement. The more storks a country has, the more babies are born in that country. How is that for the proof that storks bring babies? Okay, yeah, so this is it. This proves that storks bring babies. Done. No, okay, of course not. The common underlying cause, you can easily see the common underlying cause here, I think. The common underlying cause is the size of the country. Okay, larger countries such as Spain and Germany and these countries with large area, larger countries tend to have more birds just because they are larger, and more babies because the population is bigger. That's it. So you cannot say that this correlation proves causation. Oh, by the way, the other cause, so I'm saying that this proves that the storks bring babies. You could also say the babies bring storks if you believe in causation. Right? Of course, neither causation is true. Storks don't bring babies and babies don't bring storks. They just happen to be, there happens to be a positive correlation because of the size of the country. All right, I think I've emphasized enough of this. Let me just give you this last summary. There are three possible reasons when you see a correlation or an association. Number one, there could be pure coincidence. Okay, now I didn't explain any of these things for this one here, but there are crazy correlations people have found that are just of pure coincidence. Okay, you could also have, as I said, common underlying cause, right? And so that is the one that is probably the most, the best explanation in most of the times when you see a correlation or association. Now, when two things are correlated or associated with each other, it is possible that one is causing the other. Okay, so for instance, when you compare the people who are vaccinated as opposed to people who are not vaccinated against the COVID-19 virus, you see that the people who are fully vaccinated tend to have a very small number of new cases of COVID-19, right? So there's a clear association. The level of inoculation, the higher it is, the lower the cases of the new COVID-19 sicknesses. So that negative correlation exists. And because double-blind studies have been done on these vaccines, you could say there is a cause and effect. The vaccination causes people not to get sick with COVID-19. So that is an actually proved causation. But remember, that did not come from observational studies. That came from carefully and repeatedly conducted study, not observational studies, but experiment. And it turns out to be double-blind studies done by these pharmaceutical companies. And double-blind is the highest level of studies that people can do in these situations. So in summary, this is what I'm saying. A causes B and C. So B and C, what am I talking about? I'm trying to explain the second one. All right, so let's see, and common underlying cause is the cause A. Okay, whatever A is causing B and C to increase or decrease. So if you look at B and C are correlated with each other, but one is not the cause of the other. All right, so this could happen. Let me just make sure that you clearly understand what I'm trying to say here. This statement is explaining what I am describing as a common underlying cause. The common underlying cause is A, right? Now B and C are positively correlated. Maybe as one increases, the other one also increases. Or like in the case of vaccination level and the new cases of COVID-19 or something, as one increases, the other one may decrease. Okay, as B increases, the C decreases, right? So this is negative correlation. As B increases, C increases. That's a positive correlation. Either of these correlation may be happening not because B is causing C or C is causing B, but there is an underlying cause A, which is causing B to increase and C to increase at the same time. Or as B increases, C will decrease as A is affecting both C and B. So this is what is called a common underlying cause. And all of the examples I gave you on this page can be explained by some sort of a common underlying cause, which was hidden in the statistical study. See, these statistical studies just observed a correlation, but the underlying cause was, in a sense, a lurking or confounding variable that was not the part of the study, but that's later observed as or accepted as a common underlying cause. Okay, so what is the big takeaway here? Correlation does not imply causation. Just because two things are related to each other does not mean that one is the cause of the other. Make sure you understand this. I will emphasize this over and over throughout this course and probably throughout my life to anybody who would listen. And it is one of the greatest takeaways of this course. All right, now it's time to go to a quiz for section 5.2, both on this paper and online, and then do your homework. All right, I will see you when you are ready to study section 5.3. Take care and have a great day.